Welcome to Laser Learning Center. In this episode, we're going to be focused on anodized aluminum, and I've got a couple pieces in my hand. There's different kinds of anodized aluminum, but what laser do I want? Well, you say, well, any laser will do it, and you're absolutely right. But did you know there's different kinds of anodized aluminum, type 1, type 2, type 3? So if you break down every laser, laser is a beam of light. Okay, sure. There's different kinds of lasers. The CO2 laser has a certain wavelength, a fiber laser has a certain wavelength, a UV laser, and the list goes on. And we're going to cover all of those in this channel, so stay tuned. But the two lasers we're focused on in this episode for anodized is going to be a fiber laser and a CO2 laser. Uh, a lot of times, lasers are very specific for a material. If you had a piece of wood, the correct laser of choice would be a CO2 laser. Why? Because of reflection and absorption. If you had a piece of metal, a bare piece of metal, then the correct choice between a fiber and a CO2 would be a fiber laser because the metal is going to absorb the energy from a fiber and you can do stuff. Stuff meaning cutting and etching and polishing and welding and drilling and things of that nature. A CO2 laser on a bare piece of metal just is like a flashlight on a mirror and nothing happens until you get to many hundreds of watts or kilowatts, and you can cut right through and overcome the reflectivity on a bare piece of metal, whether it's aluminum, it doesn't matter, but high-powered CO2. But we're focusing on um, which laser do I want for anodized. So the one overlap, if you go to trade shows, if you call up a company, if you go see a demo at any laser company, very common material is anodized aluminum cards. Why? Because it's the easiest thing that you can do. And I don't care if you have a fiber laser, I don't care if you have a CO2 laser, a UV laser, a green laser, they're all going to mark just fine. Anodized is a very, very easy application. But we're going to dive deeper into the differences. So there's three types of anodized. Type 1, it's a chromic bath. It's a liquid bath. So chromic bath, and your thickness of anodizing is going to be 0.5 microns. I'll say that again, 0.5 microns. It's really, really thin. Uh, type 2 anodizing and type 3 anodizing is a sulfuric bath. So it's a little bit different. And a little bit different means also you're going to be thicker as well. So type 2, you're going to be up to about 1/1000th of an inch, which is, for our metric friends out there, 25 microns. And then type 3 is up to 3/1000th of an inch, or 75 microns for our metric friends out there. So whether you have the different ones really means everything, especially if you're in the industrial world or consumer products such as a bicycle frame or a laptop or a flashlight or a firearm. So if you had a piece, a widget, let's say, that's anodized and you put it on a ship, you don't want to have exposed metal on there, so you anodize it to protect it, and it also looks nice. So you have different colors. There's only two colors here, but you can have almost any color in the world that I've seen anyways. In fact, I think white was one that you can't get with anodizing, but um, we'd have to confirm that. But anyways, if I had a fiber laser and I had a piece of, I don't know, anodizing, and a lot of people don't know, they just buy anodize and they just mark it and it works. But in the industrial world, again, bicycle frames and so forth, if you leave it out in the elements, you don't want to have exposed metal because of corrosion. So which laser do I want? Well, type 1. Let's start with type 1 anodizing. Type 1 is so thin, and we said it's a chromic. That doesn't really mean anything to the laser, but that's just how the process is going to be up to zero point 0.7, so 0.5 to 0.7 microns. That's very, very thin. So if you had a fiber or a CO2 laser, you're blading off and you're exposing the metal. How do you test that? You can certainly take an ohm meter and test that. So take the probes on what you just etched, put the probes down on the metal, and you'll see that you'll get a short. So if you have type 2 anodizing than if you had a CO2 laser for type 2. A CO2 laser is going to bleach because the anodizing is so thick. You're bleaching the color and the bare metal is protected still. So not a problem there. A fiber laser on a type 2 can bleach, but it can also ablate off. So this is where experience is going to help. A fiber laser, typically you're going to have a power, speed, frequency, what lens are you using, a hatch fill if you're using a vector-based laser system like a galvo based. And we're going to cover all of these things in later episodes as well. But type 2, again, CO2 laser is going to bleach it typically, and you're going to have your metal protected still. And a fiber laser can be one or the other, ablation or bleaching, depending on your settings of that fiber laser. Type 3 is it's a hard coating is what it's called. Again, it's a sulfuric process, and it's up to 3,000ths of an inch, typically 1 to 3,000ths of an inch. And if you're going to be getting through that, you're going to have to hit that very hard with a fiber laser. So a fiber laser is going to, that's typically your ablation laser. You're going to be eating the metal, eating the anodize, and exposing the metal. You can roughen the surface later to make it white, but again, your metal is exposed, and now you're exposed for corrosion for later on in the elements. A CO2 laser, you're going to mark that a type 3. Again, we're on, and the type 3 is going to bleach the color. And typically what I've seen is you can get a very white mark with the CO2 laser as well. So it really depends what you're trying to do, what industry you're in. These are just two coupons, and let me show you here. One is black and one is blue, and there's something in the blue. For those experienced laser users out there, you see the top is CO2. The black one, they look very similar, whether it's fiber laser or CO2, but the blue one with the CO2, it's going to be kind of a bluish tint. And for all those experienced laser users, that's very, very common. And what I tried to do, if you had a powder coated tumbler, such as this, very common in the industry, Stanleys and Yetis and so forth, where ablating off the powder coating and exposing the metal looks really, really nice. And for those of you that do that, there's a degreaser. There's a lot of them out there. This one happens to be totally awesome. There's ZEP 505, but it's very common. They're very cheap. You go to Home Depot, it's just a degreaser, but totally awesome. ZEP 505, from what I've seen, are my top two anyways, because those are the only ones I've used, and they both work fantastic. You spray it on, and then you wipe off, and you're removing a lot of the powder coat or the residual powder coating and exposing the metal, and it works absolutely beautifully. Um, what I tried to do with this CO2, I tried to spray that degreaser on there, and I scrubbed really hard, and I tried it again and scrubbed again, and I could not remove that. So anodizing is not a powder coat, so I'm not removing the paint, but that CO2 laser, for whatever reason, it's giving a blue tint. So if you're seeing that, that's very common. I don't remember seeing that on any other color, but blue was the only one. So fiber laser is going to get a whiter mark because I'm actually ablating off and getting into the metal. When I get into the metal, I can increase the surface area and roughen the surface, and to the human eye, it's going to look white. And that's why a lot of times a fiber laser, you have a lot more flexibility with a fiber laser to make that super white or not. But I have seen CO2 laser depending on the material to get that very nice and white as well. But you're not etching into the metal at all. So just a few things to kind of look out for. But fiber CO2 anodized works great either way. Be careful if you're in the industrial world uh, to pass salt spray tests. If you have a part that's going to be on a ship or somewhere else that's going to be exposed in the elements, you just want to bleach the process and not remove it, because anodizing is a coating and it's supposed to look nice, number one, and it's supposed to protect your part, number two. So thanks for watching.